Next one is azeotropic mixtures. Azeotropic mixtures are the liquid mixture which boils at constant temperature. So this is the liquid mixture boils at a constant temperature. And distills completely at the same temperature. And distill completely at the same temperature. We can define azeotropic mixtures as liquid mixtures which boils at a constant temperature and distill completely at the same temperature. Okay, let's go to the details of this. That is, consider a binary liquid containing A and B. A is less volatile and B is more volatile. So if we draw the boiling point mole fraction curve of this, we'll get A here and B here, and this is for liquid composition curve, and this is the vapor composition curve. So this is for liquid and this is for vapor. Okay. We consider this is point C. So if we consider the point C, at C, if we boil the mixture, then both A and B boils. Right. That is, at C, both A and B boils, and I'm going to take this temperature as Tc. That is, at Tc, A and B boils. So the distillate containing both A and B. Okay, so we can say C is an azeotropic mixture. And if you observe this curve, we can see this is the C is the minimum point in this boiling point composition curve. So this type 2 binary liquids can be classified as minimum boiling azeotropes. Minimum boiling azeotropes. The composition C having the minimum boiling point among all other compositions. So the binary liquids showing large positive deviation from Raoult's law are minimum boiling azeotropes. And if you consider any other composition in the binary liquid type 2, for example, if you consider a composition X, so this is X, then if I draw a vertical line like this, the composition of X is this. Composition of liquid is this. So it will be equilibrium with the point here, that is, we can say it is X dash. Okay, so X and X dash are in equilibrium. This X composition X containing X is more closer to the point A, or we can say X is more closer to the point which corresponds to A. So X containing more amount of A and less amount of B. If we boil the composition X, then we'll get azeotrope as distillate and A as residual liquid. Since the amount of A is more in the composition X. So A is the residual liquid. That means if we fractional distillate the composition X, then we'll get azeotrope or minimum boiling azeotrope C as a distillate and A as the residual liquid. So this is about type 2 binary liquids is classified as minimum boiling azeotropes. So at the same time, if we consider a composition Y here, then Y dash will be equilibrium with the Y. So Y equilibrium with the Y dash and the composition containing more amount of B and less amount of A. So if we boil the composition Y dash also will be there. So if we boil the mixture, we'll get an azeotrope and azeotrope as distillate and residual liquid will be pure B. Then the next one is maximum boiling azeotropes. Maximum boiling azeotropes. So this is actually type 3 binary liquids. That is binary liquid showing large negative deviation from Raoult's law. So here the curve will be like this. The curve will be like this. This is for liquid and this is for vapor. Sorry, this is for vapor and this is for liquid. Here it is A and B. So I'm going to take this point as D. So here at composition D, at D, if we boil the mixture, we'll get both A and B. That is, we'll get azeotropic mixture. So at constant temperature, we can mark it as TD. At a constant temperature TD, the mixture binary liquids boils and the distill containing both A and B. So here this point D is the maximum among all other compositions. So we can call it as maximum boiling azeotrope. Same as that of the minimum boiling azeotropes, if we consider any composition X here, then there will be an X dash corresponding to X dash. So if we boil the composition X dash, it containing more amount of A and less amount B. So if we boil the mixture, we will get an azeotropic mixture with the residual liquid of A. And if we select a composition Y, and Y dash will be there corresponding to Y. So if we boil Y dash, then we'll get boiling of Y dash composition. Y composition we'll get azeotrope, the maximum boiling azeotrope as well as residual liquid. Here containing more amount of B, so residual liquid will be pure B. The next one is liver rule. Liver rule help us to find out the compositions of binary liquids and boiling point of the corresponding composition. Consider a binary liquid containing A and B. And imagine A is a less volatile substance and B is a high volatile substance. So the boiling point, we know the boiling point of less volatile substance will be greater than the boiling point of the highly volatile substance. So boiling point of A will be greater than B, right? I'm going to take the boiling point of A as TA0 and the boiling point of B as TB0. So that I can write like this: TA0 will be greater than TB0. Okay, to define the liver rule, consider type 1 binary liquid, that is binary liquid showing negligible deviation from Raoult's law, here mole fraction and here boiling point. We are considering that A is less volatile than B. So if I am going to mark B here, then boiling point of A will be high. So this will be the liquid composition, vapor composition curve of type 1 liquids. Then I'm going to consider a point A in the two-phase region, that is liquid vapor phase region. And here you have to consider that at A, there is an equilibrium between vapor and liquid. Now I'm going to take the distance between the point A and the vapor composition curve as V. So V is the distance between A and the vapor composition curve. At the same time, I'm going to consider the distance between the point A and the liquid composition curve as L. So distance between A and the liquid composition curve. And the line which is passing through this point A, the horizontal line which is passing through this line A is called tie line. So according to liver rule, the amount of liquid phase and the vapor phase related as N liquid divided by N vapor equal to the length AV divided by the length AL. So according to liver rule, the ratio of amount of liquid to the amount of vapor phase equal to the distance AV divided by the distance AL. So from this equation, it is clear that if we consider a point which is very closer to the vapor composition curve, then AV, the distance AV is very less. AV is less. Right. So from this equation, it is clear that when the distance AV is very less, then N liquid will also very less. That means the amount of vapor will be higher in the composition. Okay. On the other hand, if we consider a point very closer to the liquid composition curve, then AL will be very less and correspondingly amount of vapor phase will be reduced and the composition will contain more amount of liquid phase. So from liver rule, we can calculate the compositions. Okay. So this is all about composition of binary liquids. Now we are going to discuss the point of the binary liquids. Here also we are going to consider, we are going to draw the same vapor composition, liquid composition curve, which showing the boiling point against mole fraction of pure solvents B and A. B is less volatile substance and A is more volatile substance. And this is type 1 binary liquids. Okay. Here, between this region, this is a two-phase system. That is, liquid phase as well as vapor phase exist between this region. So, if I am going to consider a particular composition X1, then this is for liquid and this curve is for vapor. So if I heated the composition X1 to temperature T1, then it converts to vapor state, right? That is, converts to the vapor state of X2 composition. So when we boils a liquid having composition X1 to a particular temperature T1, converts to vapor phase having a composition X2. Then if I cool this vapor to a temperature T2, then it liquefies into another composition X3. If I cool again into TB0, then we can find out the boiling point of the pure liquid B. So this is how we can find out the boiling point of each compositions and the boiling point of the pure liquids A and B from liquid composition, vapor composition curve. So this is all about the completely miscible binary liquids.